And we are going to do yet another example of applying the Cauchy-Goursat theorem. So in this case, C is the ellipse. X minus 2 squared plus 1/4 y minus 5 squared is 1. So what does C look like? Well, the x coordinate of the center is at 2. Sort of the middle of the ellipse is at 2. And the y coordinate of the center is at 5. So 1, 2, 1, 2, 3, 4, 5. This is not like a focus or anything. That's where the major and minor axis meet. And we have a 1/4 here, so that tells us our major axis is the vertical axis, and we need to go up 2. So this is going to be a point on it. This is going to be a point on it because 1/4 is like 1/2 squared. And let's see, we also have an x minus 2 squared here, and so that's like a 1/1 squared. So we're going to go to the left and right 1. So we should get something like this, unless I've completely forgotten how to graph ellipses, which might be true as well. Nevertheless, that's the contour that we're integrating over. And so let's try to check the criteria for the Cauchy-Goursat theorem. So in this case, 1/z squared is the integrand. And this is analytic on any domain that does not contain 0. So let's use the domain, the collection of all z's, such that the imaginary part of z is bigger than 0. This is the upper half plane. And I'll go ahead and shade that in here in a second. Let's use light blue. So we're going to use this as our domain to apply the Cauchy-Goursat theorem. We're not actually going to be on the axis. We just get kind of close to it. All right, so is that simply connected? Well, certainly that's simply connected. So this is simply connected. Excuse me. And it's a domain because it's the open upper half plane. Let me be clear, this is the open one. And the ellipse is an example of a simple closed contour. Simple closed contours. All right, fantastic. So what do we know? Well, all of this implies, by the Cauchy-Goursat theorem, that the integral over C of 1/z squared dz is identically 0. That's it.